So this video is on Unit 11, Lessons 3 and 4. And this lesson, the main thing you really have to take away from today is knowing your unit circle and the sine and cosine value of some pretty important angles. Specifically, the angle measures of 30, 45, and 60, and all of those equivalent angles in the other three quadrants. So we will begin by talking about why this is called the unit circle. So when you think of the word unit, you should be thinking of the number 1. So that is why you will notice on the unit circle here, we've only gone out a distance of 1 in all directions. So we went right 1, up 1, left 1, down 1. All of these 4 points here are 1 away from the origin of 0, 0. So the equation of this circle, so the unit circle's equation, in case you forgot how to do the equation of a circle, since the center of that circle is at the origin 0, 0, it's going to start with x squared plus y squared. And the radius, it's equal to the radius squared. Well, the radius is 1, so it's equal to 1 squared, which is 1. Now, we can also draw in, to help us come up with some of these values, if we draw in some right triangles. So all I'm going to do is go straight down from where each of these radii touch the circle, and now I have right triangles. And I could keep doing this because you are going to be asked to come up with, you have to actually memorize these, the values for sine and cosine. And you're probably thinking, well, how do I know which one is sine and which one is cosine? Well, when you learned how to work in the coordinate plane, you named a point, its coordinates were x comma y. Well, when we are working with trig and we are in the unit circle, the old x-axis or the old x coordinate is now the cosine, and the y-axis or the y-coordinate is now the sine value. Now, the way I remember which one comes first is it's alphabetical, just like it's alphabetical for x and y. X comes first in the alphabet and then y, and then C comes before S. So that's kind of how I remember who goes first. So cosine is the first number for that particular angle, and sine is the second number. So to come up with these numbers, here's how they came up with them. First of all, let's look at 45 degrees. I'm going to draw a 45 degree angle, well, as best I can, over here, and I'm going to draw it in a right triangle. Well, if it's a right triangle, that means the other angle is also 45. This is the radius of our unit circle, which is 1. Well, because both of those angles are 45, this is an isosceles triangle, which means both of these sides I can call x. When you have a right triangle, you can use the Pythagorean Theorem to find the missing sides. The problem is you can only usually do it if you're missing one side, because you need two, you can't have 2 unknowns, you need to know 2 out of the 3. But in this case, since they're both of the missing sides are the same, they're both x, you can use the Pythagorean Theorem. So as a quick review, Pythagorean Theorem says a squared plus b squared equals the hypotenuse, or c squared. So x squared plus x squared is 2x squared. 1 squared is 1. Then in order to get x alone, you need to divide the 2 out in front over to the other side first. So that's 1/2. And then you're going to square root both sides to get rid of the radical, or the squared, sorry. Now, the square root of 1 is 1. The square root of 2 is not pretty, so you're going to leave it as the square root of 2. Back when you guys learned about radicals, I'm not sure when that was, but you may or may not, so this might be brand new, have learned that we like to rationalize the denominator, which means we don't like radicals in the bottom of our fractions, in the denominators. So what we do is we just simply multiply it by itself, because then it will be a perfect square, and the radical will go away because it'll be a nice perfect square. But whatever you do to the bottom, you have to do to the top. So on the top, 1 times radical 2 is just radical 2, and radical 2 times radical 2 is radical 4. Well, the square root of 4 is 2, so this turns into radical 2 over 2. and you will see those numbers up here near the 45-degree angle. Notice it is the same for the sine and the cosine because remember the bottom is your old x, right? Because that's your horizontal. So this is your cosine value. Well, it's the exact same thing as the vertical side, which would have been your sine or your old y. And it's the same thing. So both sine and cosine of 45 are exactly the same. They're radical 2 over 2. So that's where it came from. You don't have to know where it came from, really. You just have to memorize those numbers. So now we're going to do 30 and 60. So if you draw a right triangle, and we imagine this as it was once an equilateral triangle. So equilateral triangles mean all the sides are the same and all the angles are the same. So that means this would have been 60 over here, and the top would have been 60. But if you split that into two equal angles, they're both 30. So now remember the hypotenuse is the radius of that circle. So that's 1, which means all of the sides were 1, which means this whole side was 1. But if we're only looking at half of the equilateral triangle so that we can get 30 and 60 in one triangle, that means this side would be 1/2. Now, if you find, so the only side we're missing of that right triangle is the vertical side here. So if you do the Pythagorean Theorem, you would have 1/2 squared plus x squared equals 1 squared. So 1/2 squared is 1/4. X squared is x squared, 1 squared is 1. Subtract the 1/4 over, that's 3/4. And then if you square root both sides, you get the square root of 3 over the square root of 4, which is 2. So that means this missing side is radical 3 over 2. Now, if you're looking at 60 degrees, the bottom, remember, is your cosine, and the vertical side is your sine. So let's look over here at 60. Look at that. The first number is 1/2, which is your cosine, and the second number is radical 3 over 2, which was your sine. Now, we would normally have to do another triangle for 30 degrees, but guess what? We kind of already have it. It's just they're going to be switched. Because if I draw the 30, if you look at your 30-degree triangle, it's the cosine and the sine are switched from 60. So we don't have to redraw that triangle. You just have to know that they're the opposites. So whatever the sine was for 60, that's what the cosine is for 30, and vice versa. They switch. So that's kind of what you have to take away from this lesson. The other thing you need to remember is that sine, back from geometry, is opposite over hypotenuse. That will help you when you're trying to figure out what the sine and cosine are of certain angles. And the cosine is the adjacent over the hypotenuse. So make sure you remember those facts. Tangent is opposite over adjacent, but we don't need that for this lesson. And then the other thing that's kind of brand new is, so remember I told you that cosine is the old x and sine is the new y. Well, if you think about how to do the Pythagorean theorem using x and y, it would be x squared plus y squared equals 1 squared. Well, in the trig world, it's actually going to be cosine of that angle, theta, squared, plus sine of that angle squared equals 1 squared, which is 1. This is called the Pythagorean identity, and you have to have it memorized. But if you just simply think of it as, well, it's the Pythagorean theorem, but instead of x and y squared, it's cosine and sine squared equals 1 squared. So now that you know all these values, and again, you have to have them memorized, you also have to pay attention to the fact that some of these numbers are negative, and you just got to think back to the x and y axes. Where were you positive for the x's, negative for the x's, positive, and negative for the y's? So in this first quadrant, both x and y were positive, so that's why both sine and cosine are positive. But then if you go over here in the second quadrant, you'll notice the x's were negative. So look here, the first coordinates of each of these angles are negative, and then the sines are positive because the y's are positive there. And then down here, they're both negative, and then over here, the x is positive, or the cosine, and then the sine, or the old y, is negative. So just be careful that sometimes these values get negatives thrown in there. So now we are going to find each of these values. You can definitely find sine of 30 right away. If you look at your 30-degree angle, sine, remember, is the second number in your coordinate, so it's 1/2. Now 240, you're going to find 240's reference angle. 240 is right here in the third quadrant. To do a reference angle, remember you measure back to the x-axis or the cosine axis. So 240 is 60 away, so this is the same as the cosine of 60, but you just got to be careful because you are in the third quadrant, so you need to check if it's going to be positive or negative. So you're going to look at, well, actually you could just look at this chart, but you're not always going to have this chart. You're going to have it memorized. So if you know that 240 is the same as whatever 60 is, well, the cosine of 60 is 1/2, but it's going to be negative in this quadrant because we went to the left, so it's going to be negative 1/2. And then the sine of 5 pi over 40. Well, 5 pi over 40 as a degree is right here. It's 225. Well, 225's reference angle, how far away is it from the x-axis? Well, this is 180, so it's 45. So this is the same as 45's sine value. Well, 45 sine value is radical 2 over 2, but remember you got to check for if it's negative or positive, and it's actually negative because you're going down into the third quadrant, so it's negative radical 2 over 2. So you have to have those sine and cosine values memorized for those three angles. Any other angle, you'll be able to just use your calculator. Those are the only three we expect you to memorize. Again, you could always check it on your calculator. If you know it's one of those three, your calculator won't spit out radical 3 over 2, but it'll spit out a decimal, and then you can just say, oh, is that radical 3 over 2, and type that in and see if it's the same decimal. So you have to recognize those three numbers for those three angles. And that is it for this lesson.